first of all, thanks for inviting me to be here, Russia and the University of Sussex. It's a pleasure for me to be here. I hope to entertain you for a while and open some time for discussion after my talk. I will try to move. Okay, it looks like it doesn't work. So okay, it works. Fine. Well, something about my presentation. I will present the contents and the context of the presentation. The contents I think are more or less clear. The title is Challenges of and Opportunities of Explainable Artificial Intelligence. So most of you can more or less imagine where we will move around. And what is the context? The context is obviously me and artificial intelligence and the interaction between me and artificial intelligence, because every piece of knowledge has to be related to the context where we say that piece of knowledge. And in this case, everything I say is related with my background, is related with my history. So I will also give a little view about how I reached artificial intelligence and what has been my path in this area. So that's more or less the story. So a couple of things I want to say. The first is all the pictures. Well, there will be a couple of covers of books, so that will be real pictures. But all the pictures you will see here are artificial intelligence generated. All of them are original. Has been generated specifically for this talk with Gemini. But at the end, any misinterpretation, any wrong information there will be my fault, because I have decided to put or not to put the picture here. So I'm responsible for everything that will be shown in the pictures. And the second, the disclaimer, you will see some hallucinations in those pictures. I assume that most of you know what is a hallucination. Is the, let's say, modern and more comfortable way of saying errors, because at the end, those hallucinations are errors, are the formal definition are non-real information that is presented as a fact. So that's an error. So as we will see some hallucination, you probably know that one familiar name for all those generative pre-trained transformers, the GPTs, is Gepetto. So I think that better than Gepetto, if we will have something that is related with Gepetto, but is not human and lies, we'll have something like Pinocchio. We'll have an hallucinated Pinocchio that will generate all the pictures you will see during my presentation. So now let's go for the context. This is one of the images generated with Gemini. It's not bad in generating images, but you have to be careful. The context, me and AI. I describe as a friendship of 40 years. The 40 is not an imaginary figure, it's a real figure. Sorry. It's nothing related to wake up you, but it happens from time to time. I'm sorry, because I used to move a lot, but the micro is here. So if I move, some people will miss the talk. So you will see that I'm moving here, quite reduced. It's like the saccadic movement that we were mentioning yesterday. Well, I will do here my saccadic movement. Those 40 years goes back to the time where there was no internet, and all knowledge transfer and dissemination was printed in real paper. So I discovered artificial intelligence in the bookshop. It's a journal. This is the real journal. You can see it's 1985, so 40 years. It's true. December, almost 40 years. And I discovered that journal, that in fact it's a magazine. It's not a scientific magazine, even if the title is Scientific World, but was a good level, quite good. So I discovered that. I started to read. I discovered some people inside. I tried to contact them later, some years after that. And I finally started my career in this area. And something similar happened with the society, the vice president now, the Spanish Society for Artificial Intelligence, started almost the same age, in '84. In fact, last year we celebrated 40 years of the society. And I joined it a little bit later in '89 with some part of my, let's say, my master dissertation that was presented for the first time in a conference. So we have been together, artificial intelligence and me, for 40 years. And as said by Sebas, I haven't heard you, but I have been involved in different projects and contracts and research projects. But particularly with my personal approach, I have more or less maintained by my line of work, my line of research in knowledge reasoning, approximate reasoning, this kind of thing, not going with the wave, with the heights and downs, because, well, I think that when you find that something is the right place to be, you have to stay there, even if it's not fashioned, but I think it's better. You will be more happy and probably you will produce better results. So that has been my view. And as I will use an AI tool to generate the pictures, I decided to ask also what it knows about me. I will not say he or she for the AI, for Gemini. I will call it because for me it's it. So I asked Gemini to tell me something about me. First, I asked it to generate a picture of a young university student in mid-80s with the journal. You know that with the commercial or the open Gemini tool, you cannot put faces, personal or real pictures in the screen. So you have just to ask for someone in the university student. I accepted the face, but not bad. As you can see, the journal obviously is not the same journal, but the main ideas are there. It's the name of the title of the journal and the title of the issue. And I asked it, what can tell me about me? He said he's an expert in the field of artificial intelligence, having worked in this area for decades. Okay. Well, the expert, it's an opinion. He has given lectures on AI, including topics as explainable artificial intelligence and Industry 4.0. Well, I have given talks about that, but Industry 4.0 is not my specialty, but okay, could be. And finally, he's known for his cautious and critical thinking regarding the application of AI. Whoa. Okay, I have to explain something, maybe. So this is the context. So cautious and critical thinking. I think it's important. And finally, there's something he emphasizes the importance of interpretability and explainability in AI in context where systems interact with humans. That's true also. So more or less, the picture is not, well, not this picture. That picture is not quite far from reality. But why this cautious and critical thinking? So I started to consider, okay, why? Okay, so let's think about what I say about AI. Because if I'm cautious and critical, maybe what I say about AI has something to do with this. So what I say? What I say is that AI has a bipolar disorder. Why has a bipolar disorder? That's what usually is called the AI winters. But what are the AI winters? The AI winters are more or less a manic depression that AI suffers in times that are absolutely manic, and we will win the war, and we will do everything, and we will have general AI in 2 years. That's from the very beginning. If you read about the proposal for the Dartmouth conference, more or less they were selling that in a summer with a couple of months, 10 people there will solve some of the important problems of AI just in the summer. That was in mid-50s, so 70 years later. Okay, a little bit late. But that was part of the manic period. But after that, there were the depression period. Now we are in a manic period, but there are some messages of cooling, and cooling usually means winter is approaching. So probably we are up and close to go down. So let's see. So that's my view. Maybe I'm critical, but it's what I feel. I have been there in the ups and the downs. I was there in the 85. That was the really up of expert system, and then the downs of, and then the neural and the, so I think we have to be cautious. And main question, most of this, the depressions were related to the expectations, to what we promised and what people expected, compared with what we produced. You say, today there is a lot of things that can, I think, in products, real products, not prototypes, products that are sustainable. That's the second point. You could say, okay, we have products, yes, but are sustainable? I'm not sure. Sustainable, not only from the energetic point of view, I mean from the economical point of view. So we have to be cautious in that sense. So not so bad being cautious and critical thinking. So the main question is, if we want AI to survive, we have to be a clear idea of where we go and what we sell to the others. The question is, during these winters, research has been there. Research has been always been there, but the budget for research was not there. So was winter outside, we were in our labs, but was really cold. So, but we survived it and are here today. So, and what is one of the main questions about that? Well, one of the main questions is that people is understanding that AI is for everything, for everyone, for everywhere. And that's not true. We have not to focus in AI as the universal tool. We have to consider that it's not for everyone, because not everyone has the means, has the abilities, has the skill to access these tools. Not everyone has to be obliged to enter into this area. We have to give everybody the chance to make a decision, I want or not AI. It's not for AI because from the ethical point of view, yesterday we were talking about all medical experiments are performed with white males. So also from that point of view, it's not for everyone, because those trained systems has not been trained for everyone. So AI is not for everyone. AI is not for everything. First, not a universal solution, but even for those problems where we can use AI, maybe there are other better solutions that are cheaper, faster. So we have not to consider this as the default solution. We have not to be your students that just go to here to ask for. Maybe there are other options. Maybe why not going to the office of the professor? It's cheaper. I'm not sure it's faster, but you will do some exercise. And finally, not for everywhere. We were talking yesterday about building a nuclear power plant in close of the data center. So there are infrastructure, there are resources that not everywhere are available. So that's important. And in addition, the context is important. So those applications cannot be applied anywhere because in some cases, the context is not well balanced and the problem is that will perform wrongly. So that's my approach. We have to be clear in what we offer. And if we still allow people to think that AI is for everything, for everyone, for everywhere, the risk is the banalization. They will consider that this is like using a calculator or like taking the train. There is nothing inside. There is no risk. Oh, there is risk. So we have a tool that is powerful, that can become a strategic technology. But there are, in history, there are other tools that are powerful of a strategic technology that can change the world and are risky. So, well, here you have the first hallucination, the electrocution. So not even for spelling the words. But the question is, in the past, we have experienced many other revolutions with power engine, with electricity. And there is a transient, there is an acceptance process that requires to be carefully doing things. If we think that this is the universal tool, the universal remedy, we will lose those steps, and that will be dangerous. How many people dies in the world in a year because electric shock? I just checked it in US, 1,000 people every year for electric shock. And electric shock at home, almost 30% kids. Not in the diet, but on different levels of damage. So will you allow the kids at home to use electricity alone? Will you allow to use AI alone? Okay, maybe we have to coin something similar, to this message, to the high voltage risk of electrocution. So I have decided to create a risk of intellicution. You will be damaged by the wrong use of artificial intelligence. So maybe our AI system requires something like that. Because it's not a game, it's not a toy, it's something that could harm you. So it's something that we have to take into account. This is another risk, so I'm quite critical with that. Again, and there are additional risks. Can you imagine what is this? The typical Western movie with someone that sells something that solves any problem. So that's what is happening in some cases with AI. That was the situation in Dartmouth, but has been many other. Well, you have seen Elon Musk selling that Tesla will have in 2 years. Well, 2 other years, and so all those situations. And this is not the first time in history. Probably you know about the mechanic chess player in the 18th century. So there is a story of many let's say, selling because you are quite optimistic or because you simplify too much the problem. But now we have the additional problem of those that are selling AI that is not AI. I just checked it and took one news from past week. This is from past week. I don't know if you know Builder AI. I didn't knew nothing about that, but that's a news from June the 2nd. It's a company that supposedly just you ask for what you want in your program, say, okay, I need a program to do such and such and such. And a machine, I don't remember the name, created the code. The problem is that that machine was 700 engineers somewhere in India. And they just discovered it past week. And there was a big crash. So it's the new Dr. Cure All. But the question is that this is a great risk also for artificial intelligence. So we have our own risks, overestimate our capacity, underestimate the problems, and sell that we will solve the world. And we have the external risk, that is the bad business approaches that are also damaging the area. So maybe I'm cautious and critical, but I think there are reasons to do that. And once we have assumed, or I have provided my context, I will tell something about intelligence, because I put it sometimes yesterday, this question: how intelligent is AI? How intelligent are our intelligent machines? So are intelligent, are smart, clever, or whatever other name, are just, let's say, useful stupids? Maybe. So every time we give a lecture about that, or to our students, we go to the idea of Turing, the Turing test. Turing test, if you read the article, it's interesting. I recommend you to read the original article. It's quite interesting because the approach is, somehow it doesn't start with I will. Well, the title is Can Machine Think, I think. But the question is, he approaches in a quite a strange way, because he starts comparing men and women with auditor that is, so trying to check if it is capable of distinguishing in between a male that is saying that is a male or the other. A woman that's saying is a woman, and a man that is saying that is a woman also, and it is able to realize who one is the one who is truth. And then jumps to the idea of we do the same with a machine. So that's the approach we have used it until today. So the human that can make others to trust without seeing, just through a conversation, that is a human that will succeed in this approach. That has been then changed and added additional questions. But after that, well, we are human, and once we consider that this is the approach trying to determine if a system is intelligent just comparing with us, we have opened other approaches or other comparison, and we have checked in chess. So when Deep Blue defeat Kasparov, I think it was Kasparov in 96 or something like that, was a big change. And then when AlphaGo defeat the champion of Go, and when I think Watson went Jeopardy. So those confrontation in between the human and the machine just to demonstrate if the machine is able to beat the human as an approach to demonstrate that the machine is intelligent. Why we don't confront with other kinds of machines in other aspects? So intelligence is not only defeating a human. Intelligence may be something different. So it is important to consider. So those are the different situations. Now we have this idea, just compare the machine with the human in different aspects. But as said before, I think that there is more than that in intelligence. And if we analyze other ideas, we have people that say, okay, intelligence is not about conversation, it's not about playing chess. Intelligence is about understanding, and understanding requires consciousness. Maybe you identify this is something from Roger Penrose, Nobel laureate. So maybe he's wrong, or maybe he's true, but it is not only a comparison, it's something else. Or for others, intelligence requires embodiment. Julia, you were just talking about Rodney Brooks. That's that kind of idea. You need to interact with the world to learn, but to learn on yourself. During the dinner, we were also talking about if your kids will learn by themselves, or will learn if you push them to make mistakes. And the idea is you will only learn from your own mistakes. So probably the machine will only learn from their own mistakes. So the idea is the interaction. So there are different approaches about that, or what is usually called GoFi, the goal old-fashioned AI. Probably I belong to that area. Things that intelligence require reasoning. Yesterday, Thomas asked, I think, Sebastian, knowledge versus data. So there are different approaches. Data is enough. We need something else than data. We need some kind of, let's say, organization of that data to make possible to reason on top of that data, because probably only with data we cannot reason. We can make analogies. At the end is what machine learning does. Machine learning searches for correlation. So that are analogies. So there are different ideas here, and I think that it is important to realize that machine intelligence is not the same that human intelligence, and probably is not the same than artificial intelligence, that probably nobody knows what means artificial intelligence. And even not everybody is happy with the name of artificial intelligence. Starting with Penrose, it's completely against the name. So there are other approaches to intelligence, others that consider that intelligence requires intention. So more and more different points of view that add many other aspects, okay? Or maybe my view is that at present, AI is a quite powerful toolbox that helps you to solve many different kind of problems. It's not the universal tool. It's a quite powerful toolbox. But the question is that simply that may help us to create a change in technology, to create a change in the world. So we don't need artificial intelligence just as per se. We need something to help us solving problems. I'm an engineer. Previously to being a researcher in artificial intelligence, and my let's say my engineering soul is always there. So I think on solving problems, and I think that we have this, that is a quite powerful tool that we have to use. But we have to use the tool for those problems that the tool will help us. And for those that we don't have any other tool, you will probably use this knife if you don't have a screwdriver. Because if you have a screwdriver, probably the screwdriver will be better adapted for the problem. But enough, you can search here and probably you can use something. Okay, so that's the idea. You have something quite powerful that you can use, but maybe the first time you approach the problem, you have to do open-minded and just check for other options. Okay. So the idea is, okay, that will probably change the world, but it's not intelligence. It's not general artificial intelligence. That's quite far. Even if some people is trying to convince us that the LLMs are general artificial intelligence. I may accept our general purpose artificial intelligence, but that's different than general artificial intelligence. The general purpose is something like that, but that's not general. Okay, so here we are. After our critical approach, or my critical approach, I will not blame of you, it's my critical approach. After this critical approach, I think that we are in the place that probably we can say we want AI or not, but maybe it's too late. So assuming that AI is here and is here to stay, the question will be what AI we want. So the question will be, how will we want AI to be or not to be? That's the question, as Shakespeare said. So we have to decide how we want AI to be. And being in Europe, there is more or less a clear idea, a clear conception of how we want AI. Well, first, there is a conception of when we want AI or not, because it's that option. You know about the Artificial Intelligence Act, the AI Act. But also, once assumed that we, in some cases, we will have AI, we will ask for trustworthy AI. So those are two of the main principles in the European Union about the use of AI. The acceptance or not, depending on the risk, that is basically part of the AI Act, and also the idea of, for those applications we will use AI, we need a trustworthy AI. And what is trustworthy AI? So that's also more or less defined in the AI Act. So from one side, the risk, 4 levels of risk, and assuming that you will not use AI for those problems that are labeled as unacceptable risk, you will have a quite, let's say, restrictive situation for high level, but you will have almost no regulation at all for minimal or non-risk applications. So there will be different levels. And on the other side, the trustworthiness, and not also some human-centric, but the idea of trustworthiness that basically considers three questions that are lawful, ethical, and robust. Okay, lawful is according to rules and regulation, to legal aspects. Ethical, or respecting, that's mainly the European vision. And robust, obviously, not failing, not having problems, not blame or not producing effects in the environment, in the social environment, and so on. So the question is that with those three ideas, how will we trust machines? First, how will we trust a machine? Well, you can apply this saying to consider if you trust your dishwasher. Your dishwasher is in accordance with regulation, yeah. It's ethical, so it's let's say environmental friendly, these kind of things, and it's robust, breaks every day or not. So you can apply exactly the same approach to any machine. But the question is, what about when we are talking about a thinking machine? So you can apply that for your dishwasher, or you can apply that for your car. But what about, or you can apply that for a plane, but in the plane, you have to trust the plane or trust the pilot. There are two entities there. And what about the plane if it is an autonomous plane, or the car if it is an autonomous car? You have to trust the car, but where is the driver? How to trust that? So there are important questions that we start to open and we have to think about. We have been considering machines, but we are now considering thinking machines that somehow has some kind of freedom to make decisions. And that's the important question. And there is an interesting book about that, about how humans judge machines. And the idea is that the same situation, the same car killing someone with a human driver or a driverless car will be interpreted differently from human point of view. Will be interpreted differently because usually what they try to say, this obviously this is a real picture, it's not, it's the cover of the book, because usually humans judge other humans by the intentions, but judge the machines by the outcomes. Why? Because machines has no intention. The only thing I know is what is the outcome. So the question is, could explanations solve that question? Because will not be an intention, but at least we will somehow understand why the car killed that person. And that will allow us to have a different perspective, have a different point of view. Because if the only information you have is input-output, you can only judge from input-output. But if there is something else, if you know the change in between the input and the output, you may say, okay, that's true, because if not killing that will do that, and so there will be other effects, but you don't know why. So we are entering in the main idea. We need some kind of explanation first as a way of trusting machines. If we don't understand why the machine is doing anything, we can trust the machine. Okay, so we are approaching to the point explanation will mitigate this situation. So the idea is understanding to trust. There are some authors that say that understanding is a risk, because when you understand some cases, you will not trust, because you will understand what is happening. So brain is quite complex, and the way of thinking is quite complex, and there are studies saying that understanding is better or even is worse. But I think that it's better to explain and try to gain trust through that explanation. So those are the ideas. We are approaching the idea of if there is a decision that affects someone, we need to explain what that decision has been taken. And in that way, we will somehow understand this automated decision. And that's the field of explainable artificial intelligence. So we are starting to talk about explanations. Okay, this picture needs an explanation. What the hell has to do an apple, a painting, and some water falling from a dam? Well, all of them fall. The apple fall from the tree, the painting falls from the wall, and the water falls from the dam. So all those explanations could be interpreted as the answer to a why question. But those are different why questions. If I ask why the apple falls from the tree, you all that has a technical background will say that gravity, probably. If we make a voting, probably gravity will be the winner. Okay? So the others also fall because of the gravity. The water falls because of the gravity and the painting. But if someone asks why the water is falling from the dam, the gravity is not the answer, because the gravity will be always there, but today is falling and tomorrow will not be. Why? Because the why is probably because the dam is so full that we need to release some water, or because it's a power plant and we are generating energy, or because, so it's a different question, completely different question. So these kind of whys are different whys. For the apple, the why will be what made the apple to fall from the tree. In the others, why does water fall here? What for? What is the purpose of the water falling? And what about if the painting? Well, imagine that you are working in a museum, you are responsible for maintenance, and there are 9 paintings in the wall and 1 fall in the floor. And your boss asks, why the painting is in the floor? And you say, gravity. You will get fired immediately. So there should be another reason for that. That why was not related to physics, was related with, there are 10 paintings, 9 are properly in the wall, and 1 is in the floor. Why those are in the wall and this is in the floor? That's a contrastive explanation. It's completely different. So we have different kinds of explanations, and all those explanations will appear in our field. Those plus others, because what is the main problem here? Those whys, how come, and the what for, are mostly causal explanations. Different kind of cause, effective cause, or final cause. We can go back to Aristotle and so on, but are cause. And what's the problem? In machine learning that we are using in artificial intelligence, there are not causal relations. there are correlations. There are co-occurrences that has nothing to do with causal relation. We cannot produce a causal explanation without a causal chain. And we don't have causal chains in machine learning. Well, there are some models that we can produce knowledge graphs and conceptual graphs, these kind of things could be possible, but most of the system we are using work on correlations. And correlation has nothing to do with causality. It has to do with co-occurrence. Those that has been working in data mining know all those examples of it is dangerous to use black socks because your danger of infarct is higher, because the study was done in the city of London. So those working in those positions that require the black socks had a higher risk. But that's nothing to do with causality. It has to do with correlation. So how to explain something through correlations? Oh, difficult. We will need other means. So we have those approaches that can produce causal explanations that are mostly related with the GoFi, with the good old-fashioned AI, with knowledge and so on. And those others that are only based on data, that we will lack for that option. But there are additional questions. In Europe, apart from explaining for trusting, we have rules that oblige you to explain. We have the General Data Protection Regulation that includes a sort of right to an explanation, that if you are affected by a decision, an automatic decision, you can argue against that decision and need either or an explanation or a human intervention. So that's also legality. It's not only a question of trust, it's a question of regulation. You cannot have a system that doesn't perform with this specific feature. So that gives individuals the opportunity to challenge or to somehow interact with the system, and cannot be simply, you cannot have the loan simply deny it because of the machine says. There should be some kind of either explanation or human intervention to explain that. So that's the point. So we finally arrived. I think I'm going so slow. It's okay. Okay. You told me about 1 hour, but I have seen that the slot is 90 minutes, so I'm happy. I will try to go faster. So we finally arrived to the beginning of the talk, explaining artificial intelligence. But I think that my point is, the important question is the context. It's not that. I think that the important discussion is the previous. Here, it's something just to give us an option to open the previous discussion. So what's explainable AI? That's a field of AI that is trying to make AI comprehensible, to augment human intelligence, but with an ethical point of view for the other. I will not read that because you do have there. These techniques, explainable AI, use quite different approaches. I will talk a little bit about that. I will not enter into technicalities, but I will talk a little bit about that. And uses also different kind of explanation. But now the idea of the talk was talking about some of the challenges we face when trying to work in AI, and then some of the opportunities that will open in the field. So what are the main challenges? Well, the first, you can imagine, or AI models are more and more and more complex every time. And in addition, if they are not able to provide us with causal chains, explaining needs something else that due to the complexity, even if we have causal chains, will be difficult because the systems are more and more complex. But if not, will be challenging activity to do. So the complexity of the models, even the complexity of the explanations, and some other ideas that will appear in the following slide. So the first, about the complexity of the models. We were talking about the difference in between those models that provide us with causal chains and those others that are only based on data. From the point of view of explainability, those models that have some kind of causal chains involved are usually defined as transparent, as readable, as interpretable, and there are different of them. We have linear regression or decision trees or rule-based system or Bayesian network. But transparent is not exactly the same as explainable. Transparent usually means that we have some kind of pieces of information inside that allow us to more or less see the internal structure. But from that to an explanation, there is a long way. Once we are able to see what is inside, we have to recognize what kind of knowledge is, what kind of information. So we have to read it. And we have to merge and to combine and to understand the interaction. So we have to interpret. And only after that, we can explain. So there are several steps. Not every transparent model is explainable. And in some cases, the quest for making system more accurate breaks the structures that make it explainable. So that's a danger. And we have been always working in this trade-off in between explaining and having some accurate, or interpreting and having accurate outputs. So this kind of explanation is what is called intrinsic explainability, and is related to those models that usually are less accurate than others, but in some cases can well managed and well tuned can do some good results. The other side of the wall is those models that are not transparent, what are usually called the black box models, the convolutional, large language model, all those models that are like a black box. In those models, the complexity makes almost impossible to make any kind of explanation if we don't have additional tools. Usually, while in the intrinsic explainability, most of the system are self-explained, we can use the internal structure to explain. In those black box models, the internal structure can, first, is not accessible, second, cannot be used, even if it was accessible, could not be used for explaining. So those models are opaque, are complex, and harder to explain. And in these cases, what is the approach? Usually, we have our black box model, and we add some external structure that is the explainer, someone that explores somehow and explains. Has nothing to do with the system, but is able to understand and give some explanation. So this is the additional component we will add to the system. Typical example, probably all of you, if you have been ever working on that, you will know Line. Line, this is taken from the article. Line is a local interpretable model agnostic explanation. I will go to those terms later, but the idea is clear. You have a classifier that is quite complex and produce this classification region, the pink and the blue. And you want to explain why a specific input was classified as pink. What you do is to pick other examples, classify those other examples, and use the result of classifying. I will stay here. Sorry. Use the result of classifying those examples to create a sort of local explanation. We take a sort of closer picture where we only see a part of the examples, those we have classified, and with those we are able to create a linear separation. So that's the idea. We have a local because it's only for the region, has nothing to do with the rest. If we remove the window, we will see that has nothing to do with the overall structure, but through the window is an interpretation and provides an explanation. Okay, that's the article if you want to see, but the idea is more or less that. So that is the approach. We have to add something external that explains. We have here the idea of Line as a local interpretable model agnostic. Okay, that's related to the ideas I will say now, the specificity of the explanation. We have two different kind of approaches for this explainer. We can create an explainer that is tuned for a specific kind of models, that is a model-specific explainer, or we can create one that is model agnostic. It's independent from the model, only analyzes inputs and outputs independently of the internal structure. It's the same that if you are trying to grill a fish, you can use a basket that has the form of a fish and probably will be more efficient from the point of view of you can even use a grill that has the form of the fish, you will use less, will be less costly because you will use less coil. But you have also the option of using models that are independent of what you want to grill. So you can use a regular grill. This will be model specific. This one will be the fish basket will be model specific, while the other will be model agnostic. You can grill anything. So it's the same with explainer. You have explainers that are adapted to a specific kind of model. Others that can, line is a model agnostic because you only need the input output. Okay. More challenges when you enter in the field of explaining or explaining artificial intelligence. The context always matters. And not only the context, subjectivity. Explanation are context dependent and are subjective. So it is a quite complex situation. If you are trying to explain something to all those different people, all those different persons, they have different background, they have different information, they know different things about the problem. So you cannot give the same explanation to all of them. So that means that there is not a single explanation or one size fits all explanation. You have to take into account the purpose. Probably if you are explaining why water falls from the dam and you are a physics professor at the school, you will say gravity. But if you are an engineer in the central power plant, you will say another thing. Or if you are working in the rigs analysis department for floodings, you will say a different thing. So there will be different explanations for different contexts and for different background. You will not say the same if you are in the risk prevention system and you are talking to a politician or if you are talking to a technician, because the background is completely different. So the question is, it is quite complex. The background, the purpose, the context, the situation, you will not explain the same if you are for example, you are explaining how to put the life jacket, will not explain the same if you are just crashing the plane or if you are starting the flight. You will explain a completely different situation. So the context is also important. So explanation has to be adapted for all those questions. That's another great challenge. Another challenge is the complexity of the explanation itself, not only of the system. The more complex the system is, the more complex the model is, probably the more complex the situation will become. The explanation. So if we are trying to explain a large and a complex model, the explanation will be expensive, but not only expensive from the point of view or complex from the point of view of the dimension, will be complex from the point of view of computing. Imagine Lime. In Lime, every explanation is much more expensive than calculating the output, because for the output you have to compute a single output. For the explanation, you have to compute many outputs around that and then make a linear model. So maybe it's 10 times, 20 times the complexity of the decision itself. So you are adding complexity and your AI system will be slower. If the system was slow, now will be slower. And the other question, again, another trade-off, we have to be faithful with the model, but at the same time, we have to be comprehensible for the humans. So we cannot give an explanation that is so faithful, that is so complete, that is so clear, that overcomes the human. Too complex will be, let's say, useless from the point of view of the user. Too simple will be less faithful. So we have to balance that. It's an additional problem. So there are many challenges. There are many problems. Another question about the scope of the explanation. That will be the last word of the line. Line was a local. So we have here local and global explanations. What is the difference? A local explanation focuses on a specific output, on a specific decision. A global explanation focuses on the properties of the model. Try to describe the main characteristics, the main behavior of the model, while the local try to define why I took that decision. Okay. So we'll have the local that only considers one output and the corresponding input and try to explain why for this output I said that. Explain what is the situation. Sorry, for this input I said that. While the global try to get a sort of overall view of the behavior of the system. Obviously, it will be completely different approaches, and it will be completely different the complexity of one or the other. But this is also something you have to consider. Line is local, because at the end we are using a quite close view just to see this situation, this case, and those that are surrounding it. Okay. In the case of the global, we try to say, well, those are the important features, or this is the global bias, or things like that. So this is another of the big challenges we have when trying to explain artificial intelligence. And now I have been talking that we have causal and we have counterfactual explanations, but there are other kinds of explanations. Those of you who have worked with explainable models will know about others. Causals are mostly related with those, let's say, transparent models like rule-based system, or decision trees, and so on. The contrastive or the counterfactual are those that try to explain why this yes and the other not. For example, for the painting is in the floor because it was heavier than the others, or any other thing. But we have other kinds of explanation. We can explain somehow line works on this kind of example-based explanation with example and counterexamples. Or we can work with a prototype-based explanation. You have others like you, and you create a prototype of this type of decision. This type of decision is usually taken for this prototype. So you are perfectly matching this prototype. Or we have other kind of, for example, for global explanations, we can explain what are the most important features. That's related with what we have been working in machine learning for a long time, for feature selection and feature reaction, all those questions. So it's nothing new on the world. So that's something we are re-elaborating about things that we did in the past. Now we have textual or narrative explanations, but now we have many visual explanations, particularly for image processing. We have the silencing maps. Yesterday I have seen several silencing maps, or we have dependent clause. So we have many different of graphical explanation. And now we are entering into the field of interactive explanations, where we can interact with the system, trying to go in deep on the explanation. So there are different options. All of them are open now, and we are working in different of those ways. But there is an additional quite complex question, is the evaluation. All those coming from machine learning have been working in a quite easy landscape. Error. It is quite easy to measure the error. It's an absolute measure. We know what is the minimum. We know what is the target. But explanation. What is a good explanation and a bad explanation? What is an interpretable model and what is not an interpretable model? How to measure those kind of subjective concepts? It is quite difficult. So we move from an area where metrics were clear to an area where metrics are not so clear. And in addition, if we want to balance both of them, it is even more difficult, because you want to balance something that has a metric with something that not really has a metric. So imagine that you try to advise this couple about which one has to buy. It depends. There is not a metric. Do you want the cheaper, less consuming, stronger, more comfortable, faster? It is quite complex. And in addition, if you are searching for the most comfortable, how you measure comfortability? So it is a real challenge here. How to define or how to decide if a system is more explainable than the other. It's not an easy task. Okay, we have no metrics for this. While we have metrics for error, we have no metrics for the other part. Okay, and another of the challenges, bias. I put you this picture. Do you think there is some bias in this, in the training set of this classifier, and is some bias in the classification? What do you think? Yes? No? Not here? There is no answer. Bias is not an intrinsic property of the data set. Bias is related with the problem. Whenever you go to a company and the company says, we have a great data system, the data is perfect. For what? So data models and data sets has to be defined having the problem in mind. Because imagine that this system is made to classify people with hat. It's perfect. Obviously, if it's done for classifying men and women, it's not good. But what about if it's classifying people with a skirt? Is good or not? There will be some controversy here. A kilt is a skirt or not? Oh, okay. So that's the point. Bias is not in the data. It's in the relation in between the problem and the data. If you are trying to solve a problem, I don't know, problem related with animals, in Europe, there is no problem in not having elephants there. You don't need for your problem. So bias is related with the problem, not only with the data. And that's something quite important. We analyze bias from the beginning. No. That's quite complex. And bias is quite dangerous for explanation because the explanation can either transfer the bias to the explanation or give an explanation that bypasses the bias. So explaining something using knowledge that is not affected by the bias while the output is affected by the bias. So that will completely break the trust on the system because we'll give you a right reason for a wrong classification. That's the worst. So this is another quite important problem with the explainable artificial intelligence. And another one, and this is really challenging, privacy. When I explain, I have to be careful what I use for explaining. I cannot disclose information about others to explain why you were refused your loan. For example, even I cannot use information about you to explain why your loan was rejected if that explanation will go to someone that has no right to access that information. Even worse, if I explain why I took the decision, maybe someone can do some kind of reverse engineering and reproduce my system. So this is a really, really challenging question about the privacy when we try to explain. And this has been happening in the past, and probably some of you knows about this. Loomis, you know, Loomis was, this is a quite known sentence in the state. In the state, they use a system for analyze recidivism, so deciding what kind of sentence will provide you. So the justice uses several automated systems to determine if you will repeat your crime or not in the future. So there was a man, Eric Loomis, that was sentenced to 6 years, and part of the sentence was based on the result of this compass system, saying that has a high risk of recidivism. So he appealed, wanted to say why. I need to know the explanation why I was classified like that. And the company argued, well, I will not reveal you the formula of Coke. So I will not reveal you what is inside my system because I needed to develop that. And finally, the Supreme Court of Wisconsin decided that the way to proceed was for Loomis to analyze the factual information that was used for the system to enter the system, not the system itself. And the Supreme Court say, like Pilatus, okay, I will say nothing because anything I say can be used as jurisprudence in the future. So they prefer to, we say in Spain, the perfil, so nobody can see me. So that's what they did. So at the end, now in the state, the question is open. You can say that you will not disclose information because that's private part. In Europe, you cannot do that. because you have the right for explanation. So at the end, there is the option of not unveiling, but there will be a human that will explain why you were risked or were scored like that. Okay. So with all those ingredients, we can create our explainable artificial intelligence system that has to use the components we have here and has to consider the situations like privacy, like fairness, like performance evaluation. These are, let's say, the main ingredients. Okay, and going now to the opportunities, you have here different opportunities. Some of them are interrelated, so probably we will go faster here. I hope, because if no, I will be out of time. We have talked about trust, but we have talked about compliance, regulatory compliance, like the right one explanation. But there are other options that we can open with explainable AI. And the question is, as we are in a cooling period, maybe we are approaching the next winter. I have put those signals in that almost frozen area to try to allow us not to enter into the winter, but to navigate to, let's say, a better region using those explainable AI tools. About compliance, regulatory compliance. Well, if we have this kind of approach, we have explanation, we can trace back all the process in many cases. So it is easier to have some kind of accountability to realize who was responsible for the decision, who was the one who provided this information. So that's important. We will have also all those questions related with the regulation, with the right one explanation, and so on. In addition, we will be able to show that the decision was not made based on any discriminatory criteria. All the decision is based in information that has no sense of discrimination, and obviously to fulfill the right one explanation. So we have this idea. And here is a relation between what is compliance, that usually compliance is related to regulatory guidelines. So compliance implies some conformity with the rules, while acceptance implies some conformity, but with the individual ideas. So are related, but are in a completely different framework. One is related to formal regulations for the society. The other is related to personal information of the user, but both of them are supported by this kind of explainable AI. In addition, more things we can do with our explainable AI. If our system is a black box and there is a problem, and you only know that there is a wrong input-output relation, how you manage that? It's like if you are trying to fix an engine without seeing it. So explainable AI provide us information on how to fix the situation, how to understand the errors and the bug, how to understand the behavior. Now we have models that represent quite precisely, with a high accuracy, different real situations. But we don't understand the model, so we cannot take information from the model to understand the reality. If we have an explainable system, we can model with a quite accurate approach and then use explainability to understand not the model, but the problem itself. When I explain models to my students, I say a model is a reproduction of reality to understand reality. But if the model is a black box model, you cannot use to understand reality. So explanations can help you to understand reality. Explanation will help you also in improving the decision. Imagine that you are trying to enter the building with your source and just say no. Why? No. How would you solve the situation? But if you have some kind of explanation, you cannot enter because source are not allowed. You know how to solve the problem. That's completely different. Black box model are the policeman that is there and say no. Why? No. Okay. An explainable model is the model that gives you, in this case, can give you a counterfactual, can show you different people that enters, and those all, nobody's with source, so you probably will understand that, or directly give you a reason. So this will help you in making the right decisions, in making in solving the situation. This is the same that if the loan is denied just because it's denied, or if the loan is denied because you don't fulfill this. And in this question, it is quite important, if you give counterfactuals, it is important that those counterfactuals were actionable. That is, if I say you will not have the loan because you are too old, you have nothing to do with that. But if I provide you some reason that can be changed, you will have some ability to maneuver and to change the decision. And all that will give us the access to human-centered application, because when we have an interaction in between the human and the AI system, we need to interchange not only decisions, we need to interchange also other kind of information. So that will allow people intervene, people be in the loop or on the loop, the two approaches that we have in this kind of system, and will allow a better interaction in between the machine and the human. And the final idea is arriving to a sort of ethical AI that is related with many of the ideas we have been seeing before. It looks like an explainable system will be closer to a sort of ethical approach that we have if we have no any kind of explanation. Okay, so I'm approaching to the end. Just to conclude, I can't predict the future, not even with AI. I have tried to predict the future with AI, but I have not been able to do. So just some ideas. My view, AI is an extremely powerful tool. It's not the universal solution, but it's an extremely powerful tool. General AI, that is not around the corner. So we need, from my point of view, we need a qualitative jump to arrive to there. Not even LLMs or that people, no, it has nothing to do with general artificial intelligence. It is quite important that we were critical in what we can do and what we cannot do. We have to be optimistic, but at a level, and we have to realize what is the complexity of the problem. And the complexity is not only related with the usual complexity. We are talking about the energy and all other questions that make the situation complex. And in my view, part of the solution for some of those questions will be explainable artificial intelligence. We need that to make AI a reality at the level it can be, and not simply a solution for quite a specific problem. So I think that those are the main ideas I want to give you. And before ending my talk, I will do like in some movies, I will show you some outtakes, some of the images that the machine generated and were real hallucinations. So to close this, something for you to take. I say artificial intelligence is not for everyone, everything, everywhere, and you have to remember to be cautious. Or you know what's a Schrödinger cat? It's that cat that is dead or alive at the same time. Well, Gemini created the Schrödinger car. Can you see what is wrong there? We have a car that has a door that is at the same time an open front door and a closed back door. So if you try to enter the car and close the door, you will get trapped by the car in between two doors that are the same door. So this is the Schrödinger cat. I realized it after putting that slide on the presentation. Oh, something is wrong here. Yeah, it's really wrong. That's a real hallucination. Okay. And in addition, if you are not trapped by a Schrödinger car, you can get trapped by tragedy. Gemini was trying to convince me that the two masks was one smiling and the other sad. I asked, please, can you change one of the masks for a smiling mask? Say, there is a smiling mask in the picture. So another hallucination. And finally, once you ask for information or you use the solution, you have to be critical, but not only for being critical. to improve. When I try to get this picture, I asked for a metal protection to grill a fish on a coal, and I got that. That clearly is a metal protection to grill a fish, but not exactly the kind of metal protection I was waiting for. Okay, but it's quite creative. It's not comfortable, but okay. So that's all. I hope that you have enjoyed the talk, and I'm open for any question. Yeah.
I was just wondering how you feel, if you have any views about the new work being done to try to make black box AI systems explainable, like the Anthropic circuit tracing and the chain of thought thing.
Well, I think that it is possible. It must be possible to make those kind of black box systems interpretable. I'm not quite familiar with the approaches you are mentioning. I'm most familiar with those typical ones that we are using in image processing and so on. But the question is that we have to go somewhere there. The problem is those kind of approaches, as far as I know, are complex from the point of view of computational complexity. So I'm not sure if we are entering into a world where we use a complex problem to make to generate the output, and an even more complex problem to explain that output, and at the end that will create a quite difficult situation to manage, because we are starting to think that we have to reduce the power of our system just to make the decision. If you ask the engineers, but you have to give me room for putting my explanation over on top of that, probably they will not welcome you for lunch that day. So I think that we have to go in the same way that people is going for the decisions, trying to find simpler systems, simpler approaches with neural architecture and things like that. We have to go for something similar, because those systems that we already know clearly how to explain are those systems that are the most simple. For the complex problems, we are in a real situation where we really don't know what to do, and the solutions are more and more complex every time, and grow at the same scale or even more scale that the solution itself to the model. So I think that we have to find a different approach, because but probably I'm not really familiar with those, but what I've seen to me, it seems that we need to try all the things, but probably that would be one of the options. Well, I will check for future. Yeah.
Yeah, I think, I mean, you almost half answered it already, but I thought, isn't it possible that some black box models are just so high dimensional and complex, if you want, in some way, that they can't ever be explained to a human?
Yeah, sure. Sure. The question is that if we assume that, we'll lose the war. So
okay, yeah, but they might still be useful, right? So
yeah, no, yeah, that's the question.
Useful.
We have to, but at the end is we have to trust. Because of what? Well, because of trust. Because at the end, all those systems are not free of having those kind of hallucinations. And if you are the one that suffers in yourself the hallucination, okay, it's for the good of humanity. But I will not give you the loan for the good of humanity. So that's quite, let's say, controversial question, and we enter into the ethical aspects. Can we just charge in the back of someone the good of the rest of humanity? You will suffer the hallucination. I'm sorry.
Yeah, but it's an old question.
This is like it's like overbooking in planes.
Yeah, and there's the old question about then if you reduce the overall number of accidents with autonomous driving, but the ones that happen are unexplainable. Whereas
yeah, no, that's clear.
Human drivers, they were just drunk, so it's very explainable, but you have 10 times as many deaths. which one's the better scenario?
Yeah,
That's a very old question, right?
I quite in favor of that. In fact, if you know something about the market of the autonomous cars, in one of the places where it was more experiment was in San Francisco, and there were some accidents there. And one of the accidents that created a big controversy was because the car stopped fire car going to solve a fire. But the question is that the fire tender were driving the opposite direction. So the car was doing well, and probably whoever was driving there will crash with the fire. But the question is that was a machine. I told you the same situation with human and machine will be worse evaluated for the machine. But if we are able to explain, and the car explains that traffic light was green, I hear nothing, and it was in my lane. So probably you will accept that. But for sure, we are in a moment that we don't even know if we will be able to explain. So the complexity is so hard that we are trying. I think that there is another question I would like to say, that is, we are, many of you are working on neuro computation. And I think that we have to somehow have the clear view that something is thinking machines, another thing is building a brain. I think that was Wright, one of the Wright brothers said, if you want to fly by a plane, don't try to be a bird. If we want thinking machines, build thinking machines, don't try to build a brain. So it is interesting. We study birds to know how to fly. So we have to study brains to know how to think, probably, or not. And to learn about the brain, because that's also a quite interesting question. But we have to somehow get the thinking machines a different way, with some freedom, not to be so anthropomorphic. Because anthropomorphism is one of the problems. Why we compare them with a conversation, and then with playing chess, and then with consciousness and so on? Probably because we are continuously humiliated. We were the center of the universe, and then we were not even the center of the solar system. We are not the only one to communicate with others. We were not the only one. So our space is reduced and reduced. We want to have machines outside that. So we have to have our own space for being different from the world. And that's part of the anthropomorphic problem. So if we try to make thinking machines as small humans, I think that's a mistake. But this is my view. Yeah, Julia.
One is referring to actually the birds and playing. The first one, thank you so much for talking about accuracy in that way, because I mean, maybe it's me, but I'm done talking about accuracy, because we are adaptive and we do things good enough. We don't work for accuracy most of the time, but that is actually super nice. And the second thing is, I'm probably a bit more radical, but I would like to know your point of view on the body, right? We talked about the mind, but we never mentioned the body. The body is important, right?
Yeah, sure.
This is why it makes me do what I do, neuromorphic, but also about the fact that if you're trying to model a bird, then your model should follow that, right? Which I see completely forgotten by all of this roboticists or all of the people doing AI at the moment. They do a model and they put it in different robots, and then they tell that is embodiment, which is actually the opposite of doing embodiment, because you would refer to the fact that a robot physically is different, right? So when do you see this coming in this AI models?
Okay, just to go back to my context. My PhD was on robotics. So, but the question, I think that, as you say, embodiment is not only creating an algorithm and putting on a machine. Embodiment means that it's the machine who grows. It's the algorithm growing inside the machine. Because embodiment at the end means interaction. So it means a different way of learning. we will not learn from data. We will not learn from training. We will learn through interaction with the environment, as genetic algorithms do, or as many other algorithms that learn through interaction. So the question is that once we do this approach, in that case, we will really somehow lose the control. So will be the system itself. We have those experiments on machines exchanging messages and creating their own language and all those ideas. At the end, that is a different type of embodiment, because in that case was not a physical, but was an interaction with another virtual entity, with another machine. Here we have an interaction with the real world. So my view, that is a possible approach, but it's not the approach to the intelligent machines in the sense I'm focusing here. I'm focusing here on intelligent machines as tools to solve problems. This is the approach of intelligent machines as a new kind of entity in our world, but will not be probably those kind of embodied robots will not be industrial robots, will be home robots, or will be robots to care people, or will be this kind of robots that are not engaged in mechanic activities, that are engaged in interaction with humans. But we have to be even more careful that in any other situation, because this kind of embodied robot, for me, the only real end for them, if we want them to play a role in this world, will be for interacting with humans, and that's a real risk. That's the most dangerous place to put those. So in that case, we have to be even much more careful that with any of the intelligent machines we are talking here. So that's my view. Okay, lunchtime or no?
Oh, sorry.
No.
Well, back to Thomas's point then, if we have a very complex system with many degrees of freedom, and you try and have a post hoc explanation of it, that has to be as complex as the original
Yeah,
system.
probably.
And if we think of the human brain, we have a very complex system, and we try and explain what we've done, and humans can fabulate. Humans come up with reasons which are perhaps not the true reason. So all this suggests perhaps this is an impossible thing to try and solve in the long run. If we have a complex system, we cannot explain perhaps why the decision.
The point is that humans don't only use causal reasoning. Humans use guessing, hypothesizing, so conjecturating. So humans use many other kind of approaches.
Black box.
Yeah, but we don't even manage to understand this one. So going to the others will be even more difficult, but probably we have to try. That could be one of the shortcuts to arrive to some kind of explainability in those systems, trying to assume, but I cannot see how we will be able to find some guessing in a machine or some hypothesizing or some, we will even more difficult than that. But probably, I don't know. I know people that is working in this kind of ideas, but from the system point of view, not from artificial intelligence, just for reasoning with guessing, reasoning with hypotheses and things like that. We are, most this system are deductive or abductive reasoning simply. So it's a quite limited approach. Those that are transparent and that use knowledge, those that use data is nothing. But the question, probably we have to explore those other options. I don't know, because if you consider, for example, AlphaGo or those machines that learn to play chess, at the end is something similar to the embodiment. If you learn to play chess, playing chess, you are not using any kind of internal, you are interacting with another machine that can be done with any other approach. What kind of, is not even data, what kind of internal structure it's being created with that? So we'll just explain that, I think will be almost impossible. We can have some kind of post hoc explanation for but this is not only a decision. Playing chess is much more complex than that. So how will you explain that I sacrifice this king here, the knight or something like that? It's impossible because it's a quite complex situation. So for sure, this is not for tomorrow. I give you some days to solve the problem, but will take a lot of time to make any advancement, any, let's say, significant advancement in that way, except for those that are clear. In those cases, we know where to go. We can go step by step, but are many problems that we have no idea where to go or how to start. So will be difficult. Yeah.
Just one practical question. This is European project focus, so my question from the point of the ethical issues you mentioned during your presentation. Are we now in position, because as typically standard European approach with a lot of ethical questions in advance, to lose the war actually against the artificial intelligence, competition across the whole globe, Far East and United States, where we are now, if we keep using the approach we are using here, and then always on the bottom of this table of the competition.
I understand the question. So most people think that Europe is in a bad position due to the AI Act and these kind of things. I don't think so, because at the end, first, if you are working in your lab, you are not subject of this restriction because you are working in your lab. If you want to sell the result, then it's exactly the same if you want to sell any other product. You have to fulfill the regulation. If you want to sell your product in the States, you have to work with the rules of the state. But if any other want to sell the product in Europe, they have to work with our rules. So in that sense, I'm not sure. Another question is that we are losing the war, but not because of the regulation. We are losing the war because of the money. The investment and the budget for research is completely different. It's not a matter of regulation, because regulation will not avoid you to make research. Because what is in research, you have the sandboxes and things like that, you can do the research. The only question is, once you want to put that on market, then is when the risk of your application will be considered. But your application or the application coming from China or from the States, the ground will be the same. So you will compete in the same situation, the same conditions. So I think that the war is getting lost because of other questions, particularly investment and decision and companies, particularly companies, putting effort on that. It's my view.